Today's lesson is on specialist systems of linear equations. After today, you'll be able to understand that solutions to a system of two linear equations in two variables correspond to points of intersection of their graphs because points of intersection satisfy both equations simultaneously. You'll be able to solve systems of two linear equations in two variables algebraically and estimate solutions by graphing the equations. And you'll be able to solve real-world and mathematical problems leading to two linear equations in two variables. For our first example, we're solving a special system of linear equations. We're going to solve the system y equals 3x plus 1 and y equals 3x minus 5. First, we're going to start out by graphing each equation. When we graph the first one, y equals 3x plus 1, we can go ahead and graph it using the slope and the y-intercept. Our y-intercept is 1. So we're going to have our point right here. And then from there we can use our slope. Our slope is 3, so that'd be 3 over 1. So our rise is 3 and our run is 1. So we can go over 1 and then up 3. That will give us our next point. So this would be the line for our first equation, y equals 3x plus 1. Now we're going to graph the second one. The second one would be y equals 3x minus 5. Our y-intercept is negative 5, so we can graph our y-intercept, and then our slope is 3. So it's 3 over 1, so our rise is 3, our run is 1, so we're going to go over 1 and up 3, and then we will make our line. The lines have the same slope and different y-intercepts, so the lines are parallel. Because parallel lines do not intersect, there is no point that is a solution of both equations. So the system of linear equations has no solution. Now for our second example, we're solving a special system of linear equations. We're going to solve the system y equals negative 2x plus 4 and 4x plus 2y equals 8. Our first step in this problem is to write 4x plus 2y equals 8 in slope-intercept form. So we need to solve this equation for y. Our first step is going to be to subtract 4x from both sides. This will leave us with 2y equals negative 4x plus 8. Now we would need to divide each side by 2. When we divide each side by 2, we have y equals negative 2x plus 4. The two equations we now have are the same. We had y equals negative 2x plus 4 as our first equation, and our second equation, when we solve that and put it in slope-intercept form, we also have y equals negative 2x plus 4. The solution of the system is all the points on the line y equals negative 2x plus 4. So the system of linear equations has infinitely many solutions. When you graph this equation, it would be the same line. Now we have an additional example that goes with examples 1 and 2. You're going to solve the system of linear equations. You can pause the video and try it on your own, or you can follow along. Our equations that we have are negative 4x plus 4y equals 8 and y equals x plus 2. The first thing we want to do is we want to write negative 4x plus 4y equals 8 in slope-intercept form. So we're going to start with our equation and we want to solve it for y. We're going to first add 4x to both sides. This is going to give us 4y equals 4x plus 8. Now we need to divide both sides by 4. So we're going to get y equals x plus 2. You will notice that we now have the same equation. Our second equation at the beginning was y equals x plus 2, and our equation when we simplified or we solved negative 4x plus 4y equals 8, when we put that in slope-intercept form, we also got y equals x plus 2. If we graph this equation, our y-intercept is 2, and our slope was 1. So it would be up 1 over 1. Or we can also say down 1 and then over 1. So we went to the left that time. Since this is the same line, it would be infinitely many solutions. Now we have another example. You can pause the video and try it on your own, or you may follow along. We're going to solve this system of linear equations. We have y equals negative 5x minus 2 and 5x plus y equals 3. The first thing we'll do is we'll write 5x plus y equals 3 in slope-intercept form. So we're going to start with our equation. In order to do this, we're going to subtract 5x from both sides. So we're going to get y equals negative 5x plus 3. Our next step is to graph our equations. For our first equation, we have a negative 2. It would be our y-intercept. So I can go down to negative 2. And then our slope is negative 5. So if I go up 1, 2, 3, 4, 5, I would then need to go to the left 1 so that I can make sure that it is a negative slope. Or if I go down 5, 1, 2, 3, 4, 5, I would go to the right. So that way it would be a negative slope. So our first line would look like this. And now I'm going to graph the second equation that I had, y equals negative 5x plus 3. I'm going to first graph my y-intercept, which is 3. And then I'm going to use my slope to help me get other points. So if my slope is negative 5, I can go down 5, 1, 2, 3, 4, 5, and then I can go over 1 to the right so that it is a negative slope. I could do this again. I have 1, 2, 3, 4, 5, and then over 1. So this would be my second line. Since these lines are parallel, they do not intersect. Therefore, this system of linear equations has no solution. Now for a summary for solutions of systems of linear equations. A system of linear equations can have one solution, no solution, or infinitely many solutions. A system that has one solution would have lines that intersect. A system that has no solution would have parallel lines. And a system that has infinitely many solutions, so there would be two equations that have the same line. Don't forget to fill out your notes and remember to watch the video again if needed.